So here we have your merge sort, that is your fifth program. So here we have some errors, we'll just clear it. So I'm just directly copying the program from the manual. Don't do like that because we'll not come across what are the errors are. I'll just execute. If you observe carefully, I'll get the error here like this because I've not compiled your merge sort. What I'm doing is merge sort cannot be resolved to a type. Like still I have not compiled this program. So what I'll do is first I'll compile it. Still here I have few errors here. So here I'll just clear this. Next we are creating an C array. Right. Now this program, this file is ready. We have your merge sort main. The merge sort main, what else we have here? We have an array, we have a variables, we have a parameters to record the timings. Well, and few people are texting me like this, sir, we have a multiple makers at this line, that is your start and end are never used. And also you get something like scanner obj is never used. Until and unless you execute the program, you are not recording these values, right? You are not recording this value, so you get the error. But it is a warning. You need not worry about that. It's a warning. Just execute your program. It's a warning. Errors exist in required project. Proceed. So it is 10. Just check it out. Is that this program itself? Because even the previous program also prompted the same thing, right? We'll check it out. Is there any other errors? No, there are no other errors. So next we have alignment is must. Anyhow, if you don't follow the alignment also it works. But for you people, when you are in the exams, if you don't follow the alignment, you will not get the proper output. Means probably it will be difficult for you to resolve the errors. So this is why I opened Quicksort. It's not sort mail. Here it is. Here I have. So previously your Quicksort got executed again. That is what happens. So next we have anyhow, it will work, not a problem. So we have a merge. So there are no errors. Observe, if you follow these things, if you simply follow this thing, if you follow these things, rest all is same. Your main function is same. Only thing what I'm changing is I'm just changing this to a merge. Right now, the remaining all is same. Taking random input and anyhow, I'm just creating a object for your merge sort. And next, recording timings are same. And here, when we come to your merge sort part, observe here. So here we will not find a mid element as usually. Even in your merge sort also we have two different functions. One is simple merge. One is actually the merge. The other one is for your simple merge. And this function works recursively. This function works recursively to divide your array. And here it is used to merge your merge sort. Right? Yeah, problem. That is what we have here. We keep on like after dividing an element. If you observe carefully, keep it in mind. When I here till this statement, almost it is similar to your binary search. Till this statement, it is almost similar to your binary search program. So here I'm calculating the mid value. Usually we calculate the mid value in this way itself. So now my first part of array would look like a comma low comma mid, and whereas the second part would look like, because I'm considering the mid element also, but we didn't do this in your Quicksort. Keep it in mind, as we know that once we got the position of the pivot element, the element which was towards the left of your pivot element was the lesser elements than your pivot element. The element which was towards the right of your pivot element is greater than your pivot element. But here we are not sorting, or we are not to find that itself. It takes most of the time. So here what we are doing is we are just simply calculating the mid element by making use of the normal formula. How do we do for your binary search? But the mid element, we are just adding that mid element to your right part of the array, and we call that, we simply call a simple merge. So here in the simple merge, what we are doing is, as we know that we have two different parts of array. I'll take one element from the first part and the first element from the another part. I'll compare it. Whichever the elements is lesser, observe, whichever the elements is lesser, then I'll be copying that element to your C array. Observe carefully. Normally, we get the questions like, which is the best when compared to the both, since both your merge sort and quicksort makes use of same divide and conquer technique, which is the best one? Actually, we cannot tell which is best. Actually, it depends on the input also. It depends on the input. Anyhow, here observe how the code works. The code would tell that you have a two parts of array. You compare the first part, the first element in the first part and the first element in the second part, and whichever the element is less, imagine that the left part element is lesser, I'll be copying that to the C array. In case if the element which is present in the another part is lesser, then I'll be copying this. This is what your while loop does. This is what your while loop does. And the next while loop is like, the remaining elements are copied to your C array. In case there may be a possibility of having a maximum elements, like if it is the elements are same, then we need not execute this while loop. But if your first part array is bigger than your second part, the remaining elements are copied here. Likewise, if your second part elements are more, then that the remaining elements will be copied to your C array. But our expectation has to have this resultant in the same array itself, because I give the input in A array, right? Though I have made use of a extra memory. Observe carefully when they compare, when they tell which takes an extra memory between your quicksort and merge sort, your merge sort takes an extra memory, because whenever you compare within the same array itself, you cannot place it, right? You cannot place, there may be a possibility of missing the values. So what we do is we simply take a temporary array, we keep on adding to that temporary array. So that is what it is. So here the C is an temporary array, but the resultant has to be there in the A array itself. That is what it is. This is the end of your merge sort. When it comes to your merge sort, that is your main function. If you observe, as it is in the quicksort, we have created an object. I have created a random object to generate a random numbers, and also I have an A element, and also I have an A element, and next I have some variables here. As usually, start and end is used to record the elements, and this n is to read your elements, and as usually to get the input, observe your R. Some people may get here, sir, how does that many elements will be created? Since you are telling, right, since you are only telling that, see, for this element, for these elements like n, I have to generate a random number, and this random number will be generated by your R object. R is an object. Observe carefully, R is an object that we have created here, right? And next, the rest all is same, whatever we have considered with your quicksort. I'll just try to change here, just because it takes much of space, and even while simply displaying the elements also, instead of having a new line, I simply have a space here. And next part is, I'll try to execute this. For the first time, we simply give the small elements. So even now it is giving. These are your elements, and this is the sorted elements what we have. So where it is exactly going, observe, we have given like println. It should be like print. Println is also having a new line, right? Println is also having a new line. So we just remove that ln. Now we'll try. So it is, I'll give n elements. So these are the elements what I have. Observe, the randomly generated elements are like this, right? And the sorted is like this, right? This is what the output for your merge sorters. Like we have got the output, and likewise you have quick sort. Even you find it for the bigger elements, the your n value should be bigger. So let's check the output. So since it has taken in this way itself, because we have given us space, has not taken a new line, so I have got 15 milliseconds. To keep on trying for the at least have 5 outputs of the program for each of the things. If it is 10, then you'll get the graph and you'll understand how exactly it is. Observe